Hi everyone, in this video we're going to be learning about the decision tree model. It's a great first model to learn as it is suitable for beginners. So what is a decision tree? A decision tree is a type of supervised learning that can be used for classification and regression tasks. It makes decisions by splitting up the training set based on features. When deciding to classify a dataset, a series of questions will be asked. The questions will depend on what features the training set is composed of. The tree has nodes and it splits based on features, as shown here. In the end, it outputs a prediction. Since it is a supervised learning algorithm, we supply the features and the labels to the model. The model will work similarly to conditional statements like if or else. However, the model learns from the data itself to create those conditions, rather than the programmer creating those conditions. The more features there are, the more complex the tree can be. All machine learning algorithms have complex mathematical equations that are used by the model. Luckily for us, Python has a lot of libraries that we can use to create machine learning models. One such example is Scikit-learn, which provides a really easy interface to implement many machine learning algorithms. Using the library, we can create and train a decision tree model in just 2 lines of code. In order to use Scikit-learn, you will first need to install it. If you're using a local code editor or IDE like VS Code or PyCharm, you can install it using the pip package manager, using the command shown below. And you would have to enter this command in your terminal. If you're using Google Colab like I am, then you don't need to install anything, because it's pre-installed. And if you're using any other platform like Replit, you can do some research online on how to install packages. So after installing, we will import the tree module from Scikit-learn by typing from sklearn import tree. In this video, we'll create our own mini dataset to train the model rather than using a real-world dataset. And we'll be trying to create a model that, using data like horsepower and seats, it'll be able to determine whether a car is a sports car or a minivan. We can create our features in the form of a 2-dimensional list. So technically, it is a list of lists, and the inner lists will represent a sample containing the feature values. So we'll create a list called features equals, and using these 2 brackets that denotes that it is a list. So inside this list, we'll create an inner list. And inside this inner list, the first value will be horsepower. So if we look at the first sample here, horsepower is 300, and there are 2 seats. So this first inner list is the first sample. The next sample has 450 horsepower and 2 seats. The third sample has 200 horsepower and 8 seats. And the last one has 150 horsepower and 9 seats. So this is our features list. So after the features, we need to create our labels list. The labels will go in a separate list. This list will be 1-dimensional, so just a list of strings in our case. Instead of strings, these could also be numbers, but a string would also work with Scikit-learn. We want to make sure that the labels correspond with the features. So the first element in the labels list will be the correct class of the first sample in the features list. So for this first sample has 300 horsepower and 2 seats. So the first element in the labels list should be sports car, because that matches the data. So let's create a list called labels. And using brackets to create a list, inside these brackets, we'll put strings for our labels. So the first one is sports car. The second one is also sports car, as you can see in this table. And the last 2 are minivan It's important to match, because if it doesn't match, then the model will learn incorrect patterns and it won't be able to make correct predictions on unseen data, which is the ultimate goal. Now, since we have our features and labels, we can create the model. To create a model, we create a variable. In this case, we can call it model. we'll set it equal to tree.decisionTree classifier. It is a classifier because we're trying to distinguish between separate classes. In this case, it's sports car and minivan. In order to train the model so that it learns from the data, we call the function fit, and we pass in the features and labels using this syntax. We'll do model.fit, and inside parentheses, we'll first pass the features and then the labels. It'll use the features and labels to learn patterns it recognizes in the data. And the fit function is used to train the model, so it's learning. So let's run this code. We don't get any errors so far. And since this code ran successfully, the model has been trained. And so we can also use this model to predict unseen data. We'll test it on the following samples, as you can see here. We're testing it on 3 samples. To do so, we use the model.predict function. Model.predict, and inside those parentheses goes features, which is a 2-dimensional list like the first features list we created. Except in this new list will be the new samples that we're trying to test it on. So this is just like the features array we created before, and this time we'll pass that data set that you can see here. Okay, so the first sample has 500 horsepower, 2 seats. The second sample has 100 horsepower and 10 seats. And the last one has 150 horsepower and 6 seats. And this time we're not passing the labels list because the model will just use the features to predict what it thinks the label is. And that's what the predict function does. And so to output what the model predicts, we'll use the print function. And if we run this code, it'll output what it thinks these classes are. And as you can see here, it matches this table here. The first one it predicted as sports car, then minivan, and then minivan. You can do a similar thing for a regression, except using a decision tree classifier, you would do decision tree regressor. And also, the labels wouldn't be a class or a category. The model would instead try to predict a numerical value. Well, that's it for this video. In the next one, we'll actually learn to use a real-world data set. See you then.